Hey guys, welcome to Deep Dive Coding. Today we solve LeetCode problem of the day, that is maximum number of distinct elements after operations. So in this video I will show you how I think to solve this problem, like how I get the hint at each steps to solve this problem optimally and also the optimal solutions of it. And I will, at the end of this video, I will discuss the time and space complexity of the approach. So now let's start the video. So problem is basically says that you are given an integer array nums and an integer k. So you are allowed to do at most one operations. The operations would be the, or each element. So operation would be the, you can add minus k to the any element. So basically it convert any numbers nums array to the nums number minus k. This will be the number minus k to number plus k. So this range you can you can update any numbers of this range. And if you look into this, now let's start a simple test case. So test case would be the 8 space integer array that consists of only 1 and k equal to 3. So if you apply this operation, so if you think it carefully, like how you convert the number so that it have the maximum unique values. So you can get, first of all, if you get the range of it, so all the elements are same, that is 1. So range would be the 1 minus 3, that is k equal to 3, 1 minus 3 to 1 plus 3. So the range will be the minus 2 to 4. So there is 7 possible numbers, but the array have the 8 elements. So if you, even if you, it is not possible to convert each element to a unique value. Why? Because at max you can do these operations like minus 2 minus 1 0 1 2 3 4, but at this point, if any value you add this 1, whether it is k plus k to minus k, it will not change any other than these values already present in the array. So over here answer would be the 7. So if you look into carefully, like there are few observations. So first of all, we should take the advantages of maximum gap using the operations. That means what? Like if array elements have the maximum, if array element have the maximum value, so we want to even achieve the maximum of that thing. Like it will be the max element plus k. It will achieve the maximum of that element, so that we get the more sequence as max sequence as possible. And second observation is maximum sequence possible would be minimum element minus k and maximum element plus k. In a array we can get at max these range. So the maximum possible answers can be like maximum element plus k, like this last element, minus minimum element plus k, and middle one is 0. So this can be the at max solutions. Now let's try to build these solutions, like build this sequence as max as possible. So third observation would be like we convert the maximum number in array to maximum possible number. So already I discussed that it will be the max element plus k. And another thing after that, like this for the last element, and after that if the array element is same as the next element, so then we reduce the k so that we did not get any repetitive numbers or add the same value of k. So to do that, these operations, we need to sort the array. So after the sorting the array, from here you can get the idea of sorting. Like we need to process a sequence, so we have to sort it so that it will give like we can effectively deal with the duplicate numbers. Another thing is after the sorting, how to process the element, like whether it is goes to right to left or left to right. But here is both ways possible. Like right to left, if we consider this one right to left, then by try to maximum possible unique value number obtaining. So this means that if we go to right to left, so we try to get the maximum out of it, and but also in the mind of unique value. And if we go to the left to right, then we try to get the minimum possible number also that is unique, and that should not be equal last element. Both ways the possible you can get the correct answer of it. Now another thing is to count the how to count the unique value. So we did not have to process the set, we did not have to process the set or vector or something like that. Because why? Because this always it will be make a sequence. So to count the how many possible how many element in a sequence, we can just take a last element integer that will only consist the last unique considered element, and another one is count unique element. So these two variables is effectively count the sequence. So I think it's basic concept of the basic concept of this problem is fine. And now let's try to jump into the code, so you eventually understand what I will try to say. So first step would be, so step one is the sort the array. To process, like to handle duplicates. Now sort function in STL, sort nums dot begin and nums dot end, it will sort non-decreasing order. And after that we need to few integer variable that will, you can say, updated k, that initially it's k, it is the temporary value of k that will be, that may change in each step. Another one is last element. So last element, it will initial value, let's say infinity, that you can say int max, so that first element can consider as an answer. So we'll store the last element, last unique element, and starting from the rightmost. Another one is count unique element equal to 0. This will counts the how many distinct element in a sequence, valid sequence. Now iterate through the right to left. So this will be the step 2. Now go process each element, process from right to left. So it will be for int I equal to nums dot size -1, get I greater than equal to 0 and I minus. Now there are few cases. So case 1 would be last element of the array. So we want to last element of the array as max as possible, so we directly update that element plus k. So it will be I equal to nums dot size -1. This is the last element. So nums of I plus equal to updated k, as updated k did not change right now, so it will value of k. So effectively we are nums plus equal to k. After that it is not last element, then we have to also few cases, that is, let's say case 2, this will let's say current element equals the next element. Okay, so it will be like nums of I equal to nums of I plus 1 minus updated k. As we are updating in place, so nums I plus 1, right now it will be the initial nums I plus 1 plus updated k. So we reduce updated k so that we get the actual nums I plus 1. So if it is same like nums I equal to nums I plus 1, that means if the current element is exactly same as the last element, then we have to reduce the updated k, that will minus, and there is also a few cases. So it have to be the valid range, that means absolute of updated k. If it is greater than absolute value of k, that means it is not in the range of the k. and another thing is this. So first of all, if it is in the valid range, so we just add that thing like updated key. Another thing is, if it is not in the valid range, so as we are reducing the updated key, so we have to again increase it by 1 so that it will be in the valid range, updated k plus plus, and have two nums of I plus equal to updated k as it. So now let's try to consider this one already done. So if it is already in the valid range, so we just need to add it over here. After these things done, another thing is else of this condition. Okay, so over here it is the same as the next element. Now if it is not same as the next element, we did not update the k. Why? Because if the sequence is something like this way, that 1 2, so you have the k value is 2, so if you add it 2 over here, like 2 plus 2, that will be 4, and if you did not update the k, and 2 plus 1, it will be 3, so it will give the different value from the previous. So it will be already in it will also give the different value. So that will be the, now you just need to update the key. Updated k equal to, I will explain why I am doing this updated over here. So it will be nums of I plus 1 minus nums of I and minus 1 comma k. This will be the updated k, and nums of I plus equal to updated k. Why I do over here, like now let's consider this case. Okay, so you have 1 and let's say 10, so and k have the value of let's say 3. So if it is 3, like 10 plus 3, that will, it will give you 13. So last element would be the 13, but we cannot achieve the 12. Why? Because to achieve the 12, we need k as max, or like k have to be 11, so that we can achieve 12 by this one. So we cannot achieve the 12, so we have to go as max as possible, so that will be the maximum, that will be the 4 in else condition. Now we have to update the unique element count. So over here, if nums of I, which is already updated, is less than last element, that means it is less than the last element, then we have to update the last element as nums of I, and another thing is count of unique element plus plus, you have to increase it, and at last we have to just return the count unique element. Okay, so I think it's fine. Now let's try to yeah, it's run for the sample test case. Okay, the time complexity we are basically sorting over here, so it will take the n log n time complexity. Another thing is, we are processing each element only once, so it will take the big O of n time complexity, big O of n, and apart from that we are not taking any extra time complexity. So the total time complexity would be time complexity big O of n log n, big O of n log n plus big O of n. So you can say that it will go big O of n log n time complexity. And another thing is space complexity. We are doing the in place sorting, plus we are updating in place of nums. So, and also we taking these are extra spaces, which is constant of it. So space complexity would be big O of 1 space complexity. Thank you guys, thank you for watching. Stay tuned for more videos. I just try to submit it so that it will be accepted. Yeah, thank you, bye.